Sound energy. So energy is proportional to the amplitude. Well, related to anyway. So the more energy carried by a wave, the bigger the amplitude. You saw this with the slinkies in class. If you waved your hand more, there was more energy and a bigger amplitude wave. All right, so a low energy wave is going to have a smaller amplitude than a high energy wave. All right, so it turns out it's actually proportional to amplitude squared. This isn't something that we're ever going to work with so much in an equation, but I want you to be aware it's not a direct proportionality. Okay, and here's another animation that might help you. Okay, do you remember power? It was energy per time, or change in energy per time, really. So it's related to intensity, which is power per unit area. So watts per meter squared. So if intensity is energy over time and area, okay, then intensity is power per area. Again, this is not something we're going to work with a lot, but I want you to see this. If you're talking about intensity, it has to do with the energy, all right, per unit of time and per unit area. Okay, so a little tiny bird just makes a little squeak, all right. Your pressure wave there, all right, your power is not it's going to oscillate right in time and space. If it goes squawk, then you're going to get a lot bigger oscillation. So if you have a two-dimensional wave, intensity versus distance is an inverse square relationship. Okay, so if my intensity at A is some certain amount, all right, at B it is twice the distance from the source, so it would be 1/4. So 1 over 2 squared, 1/4 the original intensity. And at C, it's 4 times the distance from the source that A is, so it's 1 over 4 squared, 1/16 the original intensity. Okay, so again, this isn't something that I anticipate seeing a lot of problems on, but I want you to be aware of it. So let's talk about the threshold of hearing. The faintest sound that a human can hear is called the threshold of hearing. Loudness is directly related to the intensity of the sound. But the loudest sound that a human can hear is more than 1 billion times as intense as that threshold of hearing. So we put the intensity of sound onto a logarithmic scale, and we call the units decibels, all right, lowercase d, capital B. So here's this list of common sources, and you can see in the third column their intensity level in decibels, okay, and you'll notice that for every increase of 10 decibels, all right, the number of times greater, all right, you go up by a magnitude of a power of 10, so an order of magnitude, okay. So to go from 10 decibels to 20 decibels, I go up by 10, so it's 10 times as intense. Okay, so one of the loudest things on that is a player taking off. Now actually, the cell phone cuts off some of the more intense sounds. This is what it sounds like. So here's a sample question you might get about decibels. A mosquito's buzz is often rated with about 40 decibels. Normal conversation is about 60. So how many times more intense is normal conversation compared to a mosquito's buzz? Because it is 20 decibels different, it is 10 squared, so it is 100 times more intense.